In this video, we are going to go through some 1 and 2-step practice. So let's begin. Problem number 1 says calculate the number of grams in 5.67 times 10 to the 23rd molecules of aluminum. I should actually say atoms of aluminum, but that's okay. So we are given molecules and it's asking for grams. We're going to need 2 steps here because there isn't a direct way to go from molecules to grams. We need to convert to moles first. So we always start with our given. So we have 5.67 times 10 to the 23rd molecules of aluminum. And we're going to need 2 steps here. So our first step, going from molecules to moles, we need to use Avogadro's number, which is 6.02 times 10 to the 23rd. You have that many molecules in 1 mole. Okay, and our molecules of aluminum are going to cancel out. So now we're in units of moles. To go from moles to grams, we're going to need the molar mass. So for every 1 mole of aluminum, now be careful and make sure that your units are diagonal from each other. So let's take a look at the periodic table. So aluminum is 26.98. So 26.98 grams of aluminum, and let's cancel out units. So moles of aluminum will cancel out. Okay, so let's put this in our calculator. So rather than putting this all in our calculator at once, I'm going to do this in steps. So we have, for the first part, 5.67, and the times 10 to the 23rd, we're going to use the E button on the calculator. So I'm going to press second and EE. It gives me this E, and then 23. And remember, that E is the same as times 10 caret. So E, let me write this out. So E is the same as times 10 caret. So that caret is like the exponent button here. And then we're going to divide our numbers in the denominator. So we're going to divide. So divided by 6.02 E23. And then I'm going to hit enter. So here's the answer for just this first calculation right here. And then we want to multiply that by 26.98. So 26.98 over 1 is the same as 26.98. So on my calculator, I'm just going to press the multiplications button. And notice it says ANS. So that takes the entire answer from this first part, unrounded, and now we're going to multiply it by 26.98. So we get an answer of 25.41139.535. So we have 3 significant figures in our given 5.67. So we want to underline the first 3 significant figures and then look at the 4th value here. So that's a 1. That's not enough to round up. So my answer here would just be 25.4. And be careful, on the practice here, it says to not include units in your final answer. All right, let's move on to number 2. Number 2 says calculate the number of moles in 130 grams of copper. Okay, so this one is only a 1 step. To go from grams to moles, that's only 1 step. So we just need our molar mass. So we have 130 grams of copper, and we only need 1 step to convert that. So if I go to my periodic table, copper 63.55. So there are 63.55 grams of copper. That's how many grams are in 1 mole of copper. So let's put this in our calculator. So 130 divided by 63.55, and let's hit enter. So I get 2.04. Now be careful. 130 is only 2 significant figures, not 3. So if I go over here and underline the first 2 significant figures, and then I look at the third digit, which is a 4, that is not enough to round up. So my answer here should just be 2.0. All right, number 3. Calculate the number of atoms in 30 grams of silicon. So we always start with our given, which is 30. It's asking us to go to atoms. Remember, we do not have a direct way to go from grams to atoms. We have to convert to moles first. So we're going to need 2 steps here. Our first step is we are going to need to convert to moles. To go from grams to moles, we're going to use the molar mass. So silicon is 28.09. So 28.09. That's how many grams of silicon are in 1 mole of silicon. So my units of grams will cancel out. Making sure our units are diagonal, I need my 1 mole of silicon down here. And to convert to, in this case, atoms, we're going to use Avogadro's number. So 6.02 times 10 to the 23rd. That's how many atoms of silicon are in 1 mole of silicon. So let's cancel out our units here. And let's put this in the calculator. So we have 30. 28.09 is in the denominator, so we're going to divide 28.09 and hit enter. I want to multiply by 6.02 times 10 to the 23rd. So again, if I press the multiplications button, I get the ANS, and then 6.02 second E, and 23. Okay, now we are going to round this to 2 significant figures because we have a decimal. So on our calculator, 2 significant figures would be 6.4 times 10 to the 23rd. All right. Calculate the number of molecules in 4.5 moles of molybdenum, or molybdenum. I'm not sure how to pronounce that. Good luck. All right. So we start with the given, which is 4.5 moles of MO. And it is asking us to go to molecules. So we're already in grams, we're already in moles, and to convert to molecules, that's only one step. So for every 1 mole of molybdenum, we need Avogadro's number here, 6.02 times 10 to the 23rd. That's how many molecules, it should be atoms, molecules of molybdenum are in 1 mole. All right, let's do the calculation here. So 4.5 times, this is in the numerator, so we're going to multiply 6.02 times 10 to the 23rd. 4.5 is 2 significant figures, so we want to round our final answer to 2 significant figures. So it looks like 2.7 times 10 to the 24th would be our answer here. All right, number 5. Calculate the number of grams in 2.86 moles of tin, which is SN on our periodic table. So we're already in moles. We're going to grams. That's only one step. Only 2 steps when we go particles to grams or grams to particles. Okay, so let's start with our given, which is 2.86. moles of tin. Like I said, we only need one step here. We're going to need our molar mass, though. So tin, SN, is 118.71. So 118.71. Oops. Ugh, rookie mistake. Look at this. These are moles. This should be moles. Let's go fix that really quick. So for every 1 mole of tin, our molar mass was 118.71. Grams of tin. So these problems kind of correct themselves because when you go to cancel out the units, they should be the same. So if I had written my grams down here like I was about to, when I went to cancel my units, I would have noticed that they weren't the same, and I would have made the correction. Okay, so let's put this in our calculator. So 2.86 times 118.71, and again, we're multiplying because it is in the numerator. Any number over 1 is the same as that number. So we get 339.51, and this 2.86 is 3 sig figs. So if I underline the first 3 significant figures and then look at the fourth, this one's tricky because we have to turn that 9, we would go up to 10. So this would be 340. But 340 is only 2 sig figs. So to make it 3, we want to put a decimal there. Don't add a 0, we just want the decimal. All right. Number 6 says, calculate the number of particles in 1 gram of nitrogen, but it's N2. All right, so start with the given, which is 1 gram. And we're going to particles, so we're going to need 2 steps here. Remember, there's no direct way to go from grams to particles or particles to grams. We always have to convert to moles first. So nitrogen is 14.01, but it's N2, so we are going to have to double that. So it'll be, instead of 14.01, it'll be 28.02 grams of nitrogen. That's how many grams are in 1 mole. So our grams of nitrogen will cancel out. To go from moles to particles, we're going to need to use Avogadro's number, which is 6.02 times 10 to the 23rd. That's how many particles of nitrogen are in 1 mole. And again, these will cancel out. All right, so let's put this in our calculator. So we have 1 divided by 28.02. I'm going to hit enter, so that's the first calculation here. And then we want to multiply that by 6.02 times 10 to the 23rd. So times, and again, we're looking for that answer button. That will not, sorry, I lost my train of thought. So we want to make sure that we see the answer button here. Okay, and then times 6.02 E23. Okay, so there's our answer, and we want to make sure that we are rounding to 2 significant figures. That's a trailing 0 after a decimal. So it looks like 2.1. Now, even though the 8 would round the 4 up to a 5, we don't care. We're just looking at the 4. So this would be 2.1 times 10 to the 22nd, it looks like here. All right, number 7, calculate the number of grams in 3.36 times 10 to the 23rd atoms of sodium chloride. So always start with the given, which is 3.36 times 10 to the 23rd. And these are atoms of sodium chloride, NaCl. It should actually be molecules. Who wrote this practice? So atoms, it's when it's by itself. Molecules is when you have something attached to it. Okay, so these are atoms, and it's asking for grams. We know we need 2 steps. We know that we're going to need to go to moles in between. To go from atoms to moles, we are going to need to use Avogadro's number. It goes in the denominator here because these are atoms, so these have to be atoms. Atoms of NaCl. That's how many are in 1 mole. So my units are going to cancel out here. Now you can't do this every time, but here both of these are times 10 to the 23rd. So those will also cancel out. Makes our calculations a little bit easier. So now we need to convert it to grams. So for every 1 mole of NaCl, we're going to need the molar mass here. So NaCl is, let's see, Na is 22.99. Just do a side calculation here. Oops. So Na is 22.99, and then Cl is 35.45. 35.45. So let's add those two numbers together. So 22.99 plus 35.45 is 58.44. Okay, so let's fill that in on our equation here. So 58.44 grams of NaCl. Our units are going to cancel out here. Oops. Okay, let's put this in our calculator. So we don't have the times 10, so this makes our math a little bit easier. So this is just going to be 3.36 divided by 6.02. And you can only do that when you're times 10 to the 23rd or 22nd. Actually, it would only be the same if it's the 23rd. They can cancel out. It has to be the same power. Okay, so I'll hit enter. And then times 58.44 over 1 is just times 58.44. And that would be our answer. We want to round this to, it looks like, 3 significant figures. So our answer would be 32.6. All right, moving down to number 8. Calculate the number of moles in 9.85 times 10 to the 23rd molecules of technetium. Okay, so 9.85 times 10 to the 23rd. These are molecules, should be atoms. Molecules of technium, which is Tc. Now we're just going to moles. So we only need one step here. To go from molecules to moles, all we're going to use is Avogadro's number, which is 6.02 times 10 to the 23rd. That's how many molecules are in 1 mole. And again, we got lucky here. These powers are the same, so we can cancel those out, and the units. So our calculations are going to be pretty straightforward. It's just going to be 9.85 divided by 6.02. And it looks like we have 3 significant figures here. So we're going to round our final answer to 3 significant figures. But keep in mind, we want to round up, so this would be 1.64 if we are doing 3 significant figures. All right, number 9, calculate the number of molecules in 4 moles of H2SO4. So I know this looks a little scary, but the good news is we're just going from moles to molecules. We don't need the molar mass here, we just need Avogadro's number. So only one step here. So we have 4 moles of H2SO4, and for every 1 mole of H2SO4, we need Avogadro's number, which is 6.02 times 10 to the 23rd molecules of H2SO4. Okay, so moles are going to cancel out down here. So it would just be 4 times 6.02 E23. And you get 2.408. We have, this one's tricky, we only have one significant figure here. So my answer would just be 2 times 10 to the 24th. All right, last one. Calculate the number of molecules in 2.06 grams of BaI2. So that's barium iodide. All right, this one's a little tricky. So we have 206 grams of barium iodide. And we're going to molecules. We need 2 steps because there is not a direct way to go from grams to molecules. To go from grams to moles, we're going to need the molar mass. So we need barium's mass and we need iodine's mass. So let's take a look at our periodic table. So barium, Ba, is 137.33. 137.33. And then iodine is 126.9. 126.9. But it's I2, so we need to multiply that by 2. Oops. So let's do that. So let's see, we have 137 plus, would help to be on the calculator screen. 137.33 plus, I'm going to do this all as one calculation here. So I'm going to do 2 times 126.9. Okay, so we get, it looks like 391.13. So 391.13 grams of barium iodide. That's how many grams are in 1 mole of barium iodide. These units are going to cancel out. And it's asking us to go to molecules, so we're going to need to use Avogadro's number. So for every 1 mole of barium iodide, we have 6.02 times 10 to the 23rd. These are molecules of barium iodide. So these will cancel out right here. All right, let's put this in our calculator. Okay, this one's a little tricky. So we have, let's see, 206, and we're going to divide that by 391.13 and hit enter. So that's the calculation for the first step. And then let's multiply that by 6.02, and then E23. Okay. Now we have 3 significant figures here. So we want 3 significant figures, so it'd be 3.17 times 10 to the 23rd, right here. Okay. Now, while that is up on the screen, I just want to remind everybody how to type these in. I should have maybe done this earlier, but let me show you how to type this in on the practice set here. Okay, so I'm going to leave that up on the screen. Let me just erase this. Okay, so if I go to the last problem here, there's 2 ways you can do this. So if I go down here and type this in, 3.17, I can go to the little keyboard here and click the multiplication symbol, 10, and then the exponent, I can click on this button here, and I want to click on this box, and then I can type 23rd. Okay, so that's the first way. The other way that you can do this is 3.17. If you press the multiplications button on your keyboard, so that would be Shift and then the number 8, you get the little dot, which is the same as multiply, 10, And then if you press Shift and then the 6 key, that will also get you an exponent, 23. So I find this way is a little bit easier to type it in, but either way will be fine. All right, so hopefully going through those practice problems helps. If you guys have any questions, feel free to reach out. Good luck and have fun.